Hello, I'm Barend van Wyk, and I want to present a framework called the Activity Flow Spiral that might assist instructors to create learning management system contents that optimize student engagement and learning. We will first revise what is meant by the educational flow state. I will then try to link the complexity dimension of Bloom's taxonomy to the flow state and explain how these concepts can be combined to form what I call the activity flow spiral. I will also briefly comment on how the activity flow spiral naturally encapsulates different national qualification levels. Lastly, we will get to the crux of the matter, how the activity flow spiral naturally leads to LMS design that will, if correctly implemented, lead to increased student engagement and an improved learning experience. Let's start by taking a look at what is meant by the flow state, conceptualized by Michal Csikszentmihalyi. Here you can see a graphical representation of the flow state. If the challenge is too easy for the skills level, the result is boredom. And if the skills level is not sufficient for the challenge, the result is anxiety. The flow state links to the theory of desirable difficulties and the theory of cognitive overload. The flow state, popularized by Csikszentmihalyi in 1996 by his book Flow and the Psychology of Discovery and Invention, is a state that is conducive to deep immersion and engagement in a task. This task can be any activity requiring a skill, but in our case, we focus on learning. From a neurological perspective, the flow state occurs when both the ventromedial and the dorsolateral pathways of the brain are optimally activated. The flow state is experienced when someone is involved in a task. It is not a spectator experience. I now want to jump to Bloom, focusing on the educational activities that result in the outcomes described by Bloom's taxonomy. The classical Bloom's taxonomy has been revised by Anderson, Krathwohl and Bloom in 2001. It is an hierarchical model that classifies thinking according to 6 cognitive levels of complexity. Bloom implies that if a higher level of cognition or competence is demonstrated, that the preceding or lower levels have been mastered. Because the brain doesn't process in a linear fashion, many researchers criticized the proposed hierarchy. But the 6 levels of complexity remain useful and relevant to learning experience design. This is a graphical representation of Bloom's taxonomy. At the lowest level, we have remembering, followed by understanding, applying, analyzing, evaluating, and creating at the highest level. If we now link back to the flow channel, consider what is going to happen if a student is expected to evaluate and create before having mastered the basic building blocks needed to perform a task. Also think about the implications for instructional design to move a learner from remembering to creating. As proposed by William Rankin, the activities needed to move a student from rote learning to creating are direct instruction, that is traditional lecturing, reading and online material, followed by guided practice. This is where students are shown how to do calculations, perform tasks or engage with subject content. This is in turn followed by independent practice, where students complete tasks on their own, and critical engagement. Critical engagement is where students, for example, engage in what-if scenarios, and is followed by creation. Here, students produce, design, or present something, requiring the highest level of cognitive engagement. As will be explained later, we have added an additional activity called reflection. This creates a continuous feedback loop or spiral. Obviously, these activities need to be built on a foundation of social safety, collaboration, and timeous feedback. The main point is that these activities need to be consciously, meticulously, and rigorously designed and scaffolded to reach the educational outcomes. To design these activities, you need to start with what students need to create to determine what they need to evaluate, apply, understand, and remember. We need to begin with the end in mind. However, to facilitate deep learning, a feedback loop is needed. There needs to be reflection by the student on his or her learning experience, aimed at encouraging metacognition. Feedback to the instructor on what worked and what might be improved is also needed to improve the overall learning experience in future. This then brings us to the Bloom Chicks Sent Me High marriage, which I have termed the activity flow spiral. Before we consider a spiral representation, let us consider a simplified version. Here you can see skill on the horizontal axis, divided and linked to specific activities, namely direct instruction, guided practice, independent practice, critical engagement, and creation. To keep students in the flow channel, they need to learn by doing. This is where the complexity of the cognitive task on the vertical axis, as described by Bloom, is linked to a specific activity nurturing a specific skills level. The previous presentation is sufficient if we consider the smallest section or unit of a subject or module. If we consider consecutive units of a module or modules at different NQF levels linked by reflection, then the model should be expanded. So, consider 6 activities of varying complexity arranged in a circular fashion, where complexity is at its lowest in the center and increases as we move towards the edges. The flow channel now becomes a spiral. As we move through the units of a module or as we move through the modules of a course, complexity increases, creating a spiral that starts at the center and spiral outwards. Note that the reflection activity links the create activity at a lower level of complexity to direct instruction at a higher level of complexity. It should be obvious that problem and project-based learning, as well as blended learning, naturally fits into this framework. It should also be obvious that traditional direct instruction, even if it entails multimedia and online videos, is only the first activity in a series of indispensable activities to build skills. It should also be obvious by now that create activities should receive equal attention at all NQF levels and that it spans all disciplines. We will now consider the implications of the activity flow spiral on learning management system and instructional design. Remember that the flow channel spirals outwards through 6 activities and that the complexities of the learning tasks increase as the spiral expands. An LMS system has the advantage that the time spent on each activity can be made variable to suit a specific student's individual skills level. It is also possible to implement transition checkpoints to ensure that the next activity is not started unless a minimum competence for the current learning activity is reached. To recap, with thoughtful LMS design, time on activity can be completely variable and tailored to the needs and skills of a specific student. The LMS can intelligently gauge when to transition between activities to keep students in the flow channel, if utilized correctly, of course. We will now consider LMS component design in more detail. It is important to again consider this figure, which explains the different activities required to reach the desired cognitive complexity levels. Note that reflection as an activity provides a feedback loop that drives the activity flow spiral. It is prudent for every unit to start with a unit introduction, providing an overview of the contents and explaining the importance and value of the topics covered. It is also prudent to explain to the students what they need to create at the end of a unit and why this has value by referring to real-world situations, applications, and relevance. Students generally find it helpful if learning outcomes are stated unambiguously and clearly. It is also helpful to link the learning outcomes directly to the different levels of Bloom's taxonomy. The Teach Thought website contains a wealth of information, including this list of 249 verbs that can be used to describe learning outcomes at different levels. To determine what students need to remember, understand, apply, evaluate, and analyze, it is useful to start with what students need to create and then work backwards. In other words, begin with the end in mind. The first unit activity should explain what a student needs to read before direct instruction commences. This should be followed by what the student needs to watch, which may include recordings of conventional lectures. After reading and watching, a quiz or similar activity might be used to create a transition checkpoint, a mechanism to gauge if students sufficiently participated in the direct instruction activity of the unit. Direct instruction should be followed by guided practice, which can be facilitated online, in class, by the instructor or by tutors. It may include videos of guided practice, the setup of laboratory equipment, and so on. Guided practice is followed by independent practice. This, for example, may take the form of an open book, open source assessment in class or a take-home assignment. Guided practice is followed by critical engagement, where, for example, causal relationships, advanced real-life applications, and what-if scenarios are explored. Critical engagement can be designed as a group or individual activity. Critical engagement is then followed by an activity where students need to create something. This can take the form of an individual or group project, focusing on design and creation. Such a project might be a component or part of a summative project done at the end of a module. Before the current unit ends and the next unit commences, students need to reflect. Reflection should have two aims: providing the instructor with feedback, therefore replacing superficial lecturer evaluations, and metacognition, where students reflect deeply on their own learning experience. Some questions that could be used as feedback to the instructor includes: which activities excited you? What have you struggled with? If you are the instructor, what would you do to improve the learning experience? Some questions encouraging metacognition include: what seems most important about what I've learned? What should I do with what I've learned? What should I do to master what I've not yet mastered? How might what I have learned contribute to my life and society in 5, 10, or 20 years from now? For more questions, refer to the Teach Thought website. This brings us to the end of the activity flow spiral presentation. I hope that some of what I've presented might contribute to your teaching. Thank you for watching.